Molar mass is an important concept in chemistry. Molar mass, sometimes abbreviated MM, capital M, capital M. The molar mass of a substance is the mass in grams of 1 mole of particles. It happens because of the definition of the mole, it's equal to the atomic mass expressed in grams. Atomic mass is the mass of an atom or the mass of an individual molecule in atomic mass units. We figure that out from the periodic table. The molar mass is the mass of 1 mole. So we calculate this molar mass by adding the masses of each element that would be in 1 mole of the compound. We need the chemical formula to do this. So let's look at how this works. So calculate the molar mass of sulfur hexafluoride, and I'm also giving you the formula here. So sulfur hexafluoride is a molecular compound. We have 1 molecule has 1 sulfur and 6 fluorine atoms in it. So 1 mole of sulfur hexafluoride will have 1 mole of sulfur atoms and 6 moles of fluoride atoms. Because let's just think real quick about bicycles, right? That's not what I meant to do. So 1 bike. It has 1 frame and 2 wheels, right? Just very simple bicycle. 1 frame, 2 wheels. So if I have 1 bicycle, I have 2 wheels. If I have a dozen bicycles, how many wheels do I have? 24. 2 dozen. So a dozen bikes equals 1 dozen frames and 2 dozen wheels. Now that didn't work out very well, did it? 2 dozen wheels. When we look at a chemical formula, 1 sulfur atom to 4, where did that come from? 1 sulfur atom to 6 fluorine atoms, or we can insert the word dozen, or we could insert the chemist's dozen, the mole. So a dozen of these molecules would have 6 dozen fluorine atoms. Ooh, that was a save. And 1 dozen sulfur atoms. A mole of this will have 1 mole of sulfur and 6 moles of fluorine. So to find the mass of a mole, we are going to take the subscripts from this formula and multiply by the mass that we see on the periodic table. So we have 1 mole of sulfur, and how much does 1 mole of sulfur weigh in grams? 32.07. And we have 6 moles of fluorine, and how much does that weigh? Each mole weighs 18.99 stuff, or 19.00. So if we add these together, we will get the mass of 1 mole of the compound. So 32, you know, it never ceases to amaze me. I can say 7 and write 2. That's not supposed to be a 2, that's supposed to be a 7. 32.07 plus 6 times 19. And this gives me 146.07 grams. And that is equal to 1 mole of that compound. Any questions? Did you see what I did there? I'm just using the formula. There's 1 of these and 6 of those. So I take 1 times the mass of this one plus 6 times the mass of that one. I do the math, I come up with this number. Now, if this was our ending number, we would go with the 4 significant figures and round that off over here. Let's do strontium acetate. This one's a little, pardon me? This is the mass of 1 mole. So sometimes we'll write it like this, this many grams equals 1 mole. Or it could also be written like this, 146.07 grams per mole. Because we're choosing 1 mole and to find the mass of that. That's what the molar mass is. Any other questions? So let's do this one. How many strontium atoms are in this formula? 1. How many carbon atoms? 4. And how many hydrogen atoms? 6. And oxygen? 4. So remember, this 2 on the outside of the parentheses multiplies everything inside. We went over that when we talked about balancing equations, but it bears repeating. So for this one, we're going to have 1 times the mass of strontium, which is what, 87.82? 62, okay. Yeah, my eyes aren't working very well this morning. They're not getting old. 87.62. So 1 mole of strontium weighs 87.62 grams, and then we've got 4 moles of carbon. Each mole of carbon weighs 12.01 grams. We have 6 moles of hydrogen. Each of those weighs 1.008. And 4 moles of oxygen. Each of those weighs 16. Now, just a note about significant figures. I am using rounded atomic masses here. The periodic table I give you for exams has 4 significant figures for each of the masses, partly as a convenience just to make things a little more straightforward for students. Different periodic tables are going to have different numbers. Like on this one up here, lanthanum has 7 significant figures. Many of the atomic masses are known to more than 4. And so the best thing to do is use all the significant digits on whatever periodic table you are using. You do not want to round your atomic masses to the nearest whole number. That's going to cause errors. Because we're not doing super-sensitive calculations, we're just doing problems out of the textbook, 4 significant figures is generally plenty. Okay, I tend to use the 4 sig figs in lecture because a lot of these I have memorized to 4 sig figs, and so it's just a lot easier. Anyway, so there's all that, and then we have to put this in the calculator. Your calculator does understand this sort of order of operation, and so you don't have to worry about parentheses or anything. 87.62 plus 4 times 12.01 plus 6 times 1.008 plus 4 times 16 equals, and I come up with 205.708. And we can give that the unit grams per mole, or we can say that 1 mole of this is equal to 205.708 grams. That means the same thing. Because of the 4 sig figs in each of my starting masses, this would be rounded to 4 significant figures. So if this was your final answer, you would say 205.7 grams per mole is the molar mass. Any questions? You're going to be calculating molar masses quite a bit, especially once you get to 1A. And I would really recommend writing it out like this and then punching it through on your calculator twice, because it's very easy to mispress a button. You thought you pressed it, it didn't actually get pressed. Silly little mistake like that. If you do the calculation twice and you came up with the same answer, you probably did it correctly. If you come up with 2 different answers, go for best 2 out of 3. Okay? And you should always write this down, because if you make a mistake, you can go back and see where your mistake was. If you do it in your head, which is certainly possible, you could do this and just punch it into your calculator without writing anything down. If you make a mistake, then you have no idea where the mistake was, and you have to start all over again. And so it really is a time saver to write some stuff down. So any questions about molar masses and how to calculate them? No? Let's do 2 more examples. What's the molar mass of nitrogen gas? Nitrogen's an element, right? What's the formula for nitrogen gas? Is it just N? N2. Horses need oats for clear brown eyes. 7 diatomic elements. Nitrogen is the need in that sentence. So anytime we have nitrogen by itself, its formula is N2. So this is N2. So the molar mass of this gas then is 2 times 14.01, or 28.02 grams per mole. We can also write it this way: 1 mole equals 28.02 grams. How about the molar mass of ammonium phosphate? Well, how many nitrogen atoms are there in the formula? 3. So then we need to multiply the mass of nitrogen by 3, and then we're going to add the mass of all the hydrogens. How many hydrogens are there? 12. So 12 times 1.008. How many phosphorus atoms in that formula? 1. So 30.97. And then we've got 4 oxygen atoms, and those are each 16.00. So 3 times 14.01 plus 12 times 1.008 plus, oops, something went wrong. I already have 2,000 on my calculator. That's not right. Try that again. 3 times 14.01 plus, that's better, 12 times 1.008. Plus 30.97, and 4 times 16. So I'm coming up with 149. Did you guys get that same number? 149.096. If we're going to round this, because we're done, we're going to call this 149.1 grams per mole. I'd like you to get comfortable with looking at molar masses in terms of grams per mole, or 1 mole equals this many grams, because it means exactly the same thing.